Okay, good morning everybody. It's nice to see everybody's made it back. Very good. I just wanted to compliment everybody on yesterday. I thought the presentations were very, very good. I enjoyed so much of what I heard yesterday. And I thought I'd just quickly run through a couple of things that I picked up. Excuse me. I kind of see that the industry faces three significant features, and I kept hearing very similar things yesterday from all the speakers. Cost effectiveness is a challenge we all face, and you can ignore it and die, or you can do something and survive. So I thought that was very interesting yesterday. PK, we heard her talk a lot about the additives. And for me, in my industry, I thought I was very enthusiastic about the cycle time reduction. I thought that certainly appealed to me quite a lot. And also something that appeals to my quality background, and that was the color, the clusters of color tolerances, where you bring all the colors together, which is a common problem in the industry for us converters. And it's very, very good to see that, because that's clearly an issue for us in terms of changing over product diversification, because now we face a greater complexity in the supply chain, and therefore the flexibility that kind of product brings is very motivational to me, and certainly I would suggest in my converting section of the industry. Again, she talked a lot about sustainability, which was also a common theme so far. We had James yesterday who spoke about thin wall applications, and again he made very, by the way, I did manage to buy the shares of this company online last night, so they're a very good rate at the moment, so please get in quickly, because I clearly see good opportunity if the capacity has been constrained over the next couple of years for sure. Okay, all joking aside, today we have 5 further presentations, and looking down there's some very exciting presentations and content, and I'm certainly going to learn a lot today. Particularly from a couple of areas that I know very little about, and I think our industry knows very little about. But again, it follows on from the sort of theme that I saw yesterday, and indeed I feel as an industry that we face. And without further mention from me, I'd like to introduce Patricia Murray from NetEco.
I don't know if any of you really can separate NetEco from EPI. You probably see both names and wonder, well, what are they, NetEco or are they EPI? NetEco is a very young company. We have been around less than a year, and EPI is our first product that we're bringing to market. We're dedicated to finding solutions in various industries for environmental issues. It's quite a confusing time right now for a lot of industries going in and trying to find solutions these days. So this is a great opportunity for us to be face-to-face with people in the plastics industry, because we're not actually from the industry. So it's been valuable for us to be able to speak with you one-on-one, and I look forward to speaking with those of you who haven't had a chance yet. So anyway, I wasn't really sure what you knew about the topic. Thank you. And I'm finding that maybe some of you know something, a lot of you don't know a lot about what I'm going to be talking about today, and that is biodegradable, degradable, compostable plastics. Okay, so I'll talk to you a little bit about the current situation. I think that's worth addressing. How effective the solutions are right now. Some of the statistics may be a little bit surprising to you. And how they affect your business. And then the current options when it comes to different products you can use for biodegradability and so forth, and pros and cons. I think we'd be remiss if we didn't talk a little bit about the problem. I think we all know it's there. The environmentalists are doing an amazing job of keeping us all aware of the solid waste problem in the plastics. They don't go away readily. They're around for hundreds and thousands of years. I think I read somewhere an incredible number. Since the 1950s,
when plastic started really prolificating. We're seeing somewhere around 1 billion tons of plastic that's still around, that's come to the end of its use. That's a lot. It's a pretty, I can't even imagine what that looks like. Certainly it's a necessary evil that we have to start thinking about this, not only from being forced to in order to compete in the marketplace. I think you've all seen the statistics, you've all seen the pictures, so I'm not going to give you a lot of statistics here, but it's pretty visible. We know it's around. So where is it? What happens to the plastic now when your products come to the end of their life and their usability? Some of it's recycled. As we've all been hearing, the surprising statistics are now being made public. It's not a lot. I think from a consumer point of view, when we think of recycling, most of us think of bottles, single-use bottles, but it's a lot of other things. There's a lot of miscommunication about recycling. It isn't always post-consumer recycling. When you buy a product that's recycled, a lot of times it's just industrial recycling. Certainly that will probably change. There'll probably be some rules coming up where you have to be more clear. Is this industrial recycling or is this really post-consumer? So some of the marketing benefit that you get from stamping something recycled when it's really not post-consumer may be going away in the future. Pretty much the majority of our plastic waste winds up in the landfill. That can mean many different things. Here in Southeast Asia, it could be a well-managed landfill, it could be a sanitary landfill, or it could be open dumping, which we see a lot in a lot of Southeast Asian countries. Industrial compost, very low percentage, even in the States, but particularly throughout Asia, with the exception, I guess, of Singapore. You have industrial composting here a little bit, but in Thailand, for example, where we are, there is industrial compost facilities, but they're not being used because they're expensive to run, and the compost is not marketable because the fertilizer is cheaper. Solutions. I think everybody that's come up here, I don't know, when I've heard and looked at some of your presentation slides on the CD, we've all got our list of R's. So I've got mine. I've got, from a consumer point of view, we've all heard recycle, reuse, reduce. So these things mean different things to the consumer than they do to the plastics manufacturer. I've added one, this is kind of our own one that we came up with, our own R, is return. And by return, I mean return to the earth. I'm talking about biodegradability, degradability of plastics, bioplastics, that sort of thing, composting plastics. So let's see how we're doing with this. Recycling. Now you've got industrial recycling and you've got post-consumer recycling. And as we know, a lot of recyclables don't actually get turned into the products that they once were. They get turned into something else. So if the demand goes up for that particular product, you get an increase in virgin plastic manufacture. So a lot of times recycling as it stands right now, number one, it's not widely implemented, not enough anyway, and number two, it can actually cause the demand to go up. Reusability, again, means something a little bit different in the industry than it does to the consumer. Certainly not good news for the plastic industry if we start reusing everything and not buying more plastic products, but for recycling and reusability, it's also not viable for a lot of plastic applications. A lot of films, bags, and things like that are not reusable. The other side of this, reusable bags, bringing that up, quite often they're made from woven PP, which is plastic. Good news for those of you who make that product. So now we get to return. Return is really viable for most packaging needs, particularly with PE, PP, PS. It is possible to make your plastics very easily to make them biodegradable, degradable, or compostable. And it is effective. Effective particularly because it doesn't require any change in behavior of the consumer, which we know consumers' behaviors are very difficult to change and quite slow. So what are our options? If we do decide that we want to get involved and use the return solution, you've got primarily two proven categories, and this is pretty much it. There are other things out there, but again, not proven, but there's a lot of skepticism around a lot of these other products, so I'm going to stick with that the scientific community kind of understands and agrees with. The hydro biodegradables, which are, for sure, what's commonly termed bioplastics, although both could probably be termed bioplastics. I would say bio-based plastics. Remade from renewable plant products, corn, sugar, and so forth. These are the ones I think Kathleen brought up yesterday. Examples, PLA, PHBs, BHAs, those types of things. And then you've got petro-based, and then you've got hybrids. Some of these compostable to some degree. Most of them are compostable, but not biodegradable. They are biodegradable. We'll talk about that in a minute. The other ones would be oxo-degradable. As you may or may not know, plastic will degrade. It just is a matter of how much time. You do put, I guess, antioxidants in plastics to keep their shelf life for exactly the time that you want. But there is a time when you would kind of like to reverse that, and you'd like it to break down, particularly in a landfill situation. So what you can actually do is add additives to a certain amount, so that you can actually dictate the shelf life to when you want that to start to degrade and speed it up with an additive, an oxo. Okay, the difference being that the hydrodegradables degrade by the hydrolysis taking place first, and then the microorganisms taking over once there's water inside the molecule. That's a pretty fast process, so it's actually considered one stage even though it's two. The oxidodegradables are considered two because the oxidation process requires heat or mechanical stress or light in order to get the oxidation happening before the hydrolysis can take place. It's interesting to note that you can't call that bag biodegradable, but you can call the bag that's begun to degrade biodegradable. It's the terms, the way they're used are very specific. Byproducts being carbon dioxide. Yes, it's a greenhouse gas, not great, but it's much better than nothing. I just put this up here. I think you all know this, but there are regulatory standards that go along with these products. Of course, you need to make sure that what you're considering does pass the ordinary regulatories. What a lot of you'll see is the ASTM standards quoted most often when you're looking at these various products. When you're looking at hydros, there are many ASTM standards that go along with these types of products, depending on if you're coating paper, if you're just using plastic, all sorts of things. But basically, if it's just the plastic itself or the additive itself, you'll hear these most often. So I wanted to keep a low number so you would remember just these three. The ASTM D6400 is usually quoted or cited along with EN 13432, the European standard. There are other standards, ISO and so forth, but these are the ones you'll hear most often. Hydros use the composting standard. This one is used by a couple of those products which have kind of a dubious reputation in the scientific community. We don't really know what they are or if they really work, because they're tested to this standard that is an extremely bioactive landfill. They get around the problem of there not being a lot of oxygen at the landfill, but they're so bioactive in this particular test, it's not realistic. It's almost like a bioreactor. So we're not too sure about those. ASTM 6954 is a test method which will test the rate of biodegradability, degradability, and then biodegradability in that two-stage process where oxidation is necessary. That's the one that OXOs will use. Okay, I put these up there, I'm not gonna read them to you, they're on your CD if you want them. ASTM is very clear, the way they define compostable, degradable, and biodegradable. And they're different things. And oxo-biodegradable, oddly enough, they don't define, but, this is the one that's spelled out very clearly in ASTM 6954, which is the test standards. Is everybody familiar with ASTM? I think you must use it for many things in your industry, right? Okay. So these test methods and so forth are decided by a consortium. Okay, here's the three inconvenient truths when you're considering this type of option. A compostable, anything that's deemed compostable, just by nature of the fact that in a compost it biodegrades, can be called biodegradable. However, that doesn't mean it's going to biodegrade in a landfill. So be careful that way. A lot of manufacturers and so forth like to say that compostable items are biodegradable, but you have to consider only an industrial compost facility. Number two, as I alluded to, there are no current standards that really represent or simulate a real landfill situation. So of course, you've got the plant-based plastic manufacturers out there saying, oxos don't work, there's not oxygen in the landfill. Well, we don't know that. We can't really go out, well, we do know that, but we can't go out and quote a standard because there isn't one. And so that number three follows, independent testing is crucial. So when you're dealing with manufacturers or providers of solutions, and they're shoving their test data in your face, you really have to consider it. If you have an unusual application that hasn't been tried and true, like bags or caps or bottles that normally we use these products in, you may have to do quite a bit of testing, and most manufacturers are more than willing to work with you. They usually provide the additive, no charge for you to work through that with you. It's worth noting, as we probably all know, there's two types of biodegradation. One is aerobic with oxygen, which of course the byproduct is carbon dioxide. Anaerobic, not much actually biodegrades without air, but there's a second anaerobic biodegradation that occurs that produces methane. And methane, of course, is 24 times the strength of a greenhouse gas than CO2. So certainly, if you can biodegrade with CO2 as a byproduct rather than methane, that's certainly to your advantage. One more thing about bioplastics, and I found this really interesting. If you consider the really big picture of this, and actually what we were talking about yesterday, the opinion on this, if everybody were to convert to bioplastics, and I'm not saying that they don't have a place, absolutely bioplastics are very exciting, and in the future, I think there will be a move, particularly with medical applications and maybe cosmetic applications. And I put as a con, I guess the percent additive is specific to each. I don't know if you might consider that a con. It's actually just a function of the way it works. So considerations, when you're choosing where is the end of life of the plastics that we're manufacturing, depending on where you are in the supply chain. Bear in mind, the decisions that we all make now are going to be with us for a very, very long time. But take a look as time goes on. Where do your products really end up, and what can you really do about it to help with the plastic waste situation? And then when you choose, you have to think about production speed, production cost, retooling, and so forth. And really, I put cost at the bottom because that really is where it belongs. In some cases, the cost is offset by making your product different, differentiating your product from another product, which you can regain. In many areas, I know in the U.S., there's for example, a bag tax on bags coming from the region because they can't compete. American-made bags can't compete, so like products coming in are taxed. So maybe if you differentiate your product and it's not compared with like product, you won't get that trade imposed tax. So there's other ways that costs can be worked out, and the cost, when you're considering ASO, really isn't that much. Okay, now I'm gonna put my EPI hat on. These are some applications from products. All these products can be biodegradable. I know this stuff. Pretty much anything that's PP, PS, or PP can be biodegradable. Who's using? A lot of people. Thank you.
Thank you very much. Yep, is this with me? Thank you very much, Patricia. Yes, I thought I would learn.